At the same time, our catch is declining from our reservoirs, ocean and backwaters. But when the demand is increasing, we have to cater for. Today, we have the technology for breeding the poultry or goat. We are producing continuously, and if you go to market, you are readily, the item is available, you can buy it, take it to go. Likewise, fish varieties, commercially important varieties, we have to breed. For that, there are many research is happening in all the countries. Last 50, 60 years, the technology has developed. So we can develop culture of fish, we generally call it as aquaculture. Like fish culture is a specific term to culture the fish. Aquaculture is whatever you are culturing in the water. Aqua is water. Whatever you are culturing in the water, that is called aquaculture. Either you can culture fish or crab or shrimp, seaweed or any plant you are culturing, everything comes under aquaculture. Like how aquaponics you might have heard. If you are maintaining an aquarium tank in the house, you can the wastewater you can use it for culturing the plants. That is called aquaponics. Like that, the aquaculture is culture of fish and other organisms in water. We can classify them into three categories. Freshwater aquaculture, where fish, crustacean, ornamental fish, algae, everything is cultured. Brackishwater, like shrimp, crab and fishes, where the salt level is very lower than the seawater, there we can culture fish. Then mariculture. Today, all these years, we are using our oceans only for fishing or navigation, transportation of materials from one country to other country, and our surveillance purpose. So, Navy is using. Apart from that, we never attempted to culture fish in the open space. Now we have started culturing of fish in the cages in the open water. That is called the mariculture. We can culture fish, lobsters, and other varieties in the open water. How we are culturing fish? Different types of culture methods are there. Like you can construct a pond, earthen pond, like Chennai, villages they make a small earthen pond where you can culture the fish. By putting small meshes, we can pen culture we can do. Likewise, open water culture in village tanks and the lakes, reservoirs, we can do fish culture. We have raceway culture systems in upper class sections like the Himalayas, Jammu Kashmir and other places we can culture. Then recirculation aquaculture systems, this is the recent concept. With the limited water, you can recycle the water and produce more fish in a small contained area. That is recirculation aquaculture system. Biofloc and aquaponics are other techniques. So India is the leader in fish culture in 1950s. So first of all in the world, first time the fish was artificially bred. How we are breeding the chicken artificially. Similarly, breeding the fish artificially was first done by these two scientists, Dr. Viralal Chowdhury and Ali Kundi. These two people found how to breed the fish in the captive condition, the land-based system. So that we are celebrating every year on 10th July as the National Fish Farm. So this breeding technology, all the Southeast Asian countries, scientists and technicians came to our country and learned the technique. Today they are producing more than 20 to 30 varieties of fishes. And we are producing nearly 1 dozen varieties of fishes. So today we do farming in earthen pond, tanks, reservoir, cages and raceways. Today we are self-sufficient, self-reliant India. Under that we are having all kind of hatcheries, feed mills, everything we are self-reliant. We did not import it. Except the shrimp products remain not produced from our country. We have a number of feed mills to produce feed for the fish that is being supplied through a network throughout the country. So there is no shortage of feed. And we have a harvesting mechanism and transportation to all parts of the country. The fish is caught in Kokura, it can reach Chennai or it can reach to Calcutta. There is organized network of people. Even fish caught at Nagapatnam, it travels up to Visakhapatnam or sometimes to Calcutta. Even Delhi, the fish is sold. Marine fish which is caught from Tamil Nadu coast or Andhra coast, it is transported by air or by road, it is sold. But everywhere now fish availability is increased, but specific varieties cannot be available. So this is the freshwater aquaculture. You may see normally seeing in the fish market, rohu, katla, paku, pangasian, these are the varieties are coming to the market. These are costing about 100 to 150 rupees per kg, and the farmers are selling at the farm gate price of 60 to 70 rupees per kg. And the freshwater prawns can be a big one which people are culturing nowadays. In Andhra Pradesh, many farmers are doing. Tilapia and marul you can see normally in the market. This is costing about 100 rupees. Tilapia is costing about 100 to 150 rupees. Marul is costing about 200 rupees per kilo. So these fishes all we can normally see. This is all coming from freshwater system. Freshwater means your potable drinking water system. It is all in ponds and cold water fisheries. Places like Jammu Kashmir, Himachal Pradesh, Uttar Pradesh, Sikkim, Arunachal Pradesh, Nagaland, Meghalaya, Manipur, all these places, very cold climate is available. So certain fishes will grow in very low temperature. Like in Tamil Nadu, Ooty, there is a place called Avalanche, where there is a fish breeding unit established during British period, still it is continuing. So these cold water fishes are very, very costly. They are 1,500 rupees per kilo. These fishes are very delicious. So there are breeding units are there. Our Central Institute for Directorate of Cold Water Fisheries Research in Bihar, Uttarakhand, we are supporting the farmers to breed and rear these fishes. As I told earlier, fish consumption is steadily increasing because people got a lot of awareness on cardiovascular disease, stroke, obesity, and metabolic syndrome, diabetes. Everywhere if we consume fish, it can reduce the problem. Then globally also there is a demand, and due to various lifestyle diseases, it's all well documented. We can control by feeding with fishes. So the Brackishwater Aquaculture 3.9 million hectares are available in our country, out of which 1.25 million hectares are suitable for the culture of fish and prawn. But we are not using them, only 10% we are using, nearly 1 lakh hectares we are using, and 1,25,000 farmers are involved in fish culture in our country. Apart from this, if you go to inland areas like Rajasthan, Haryana, Punjab, Uttar Pradesh, Maharashtra, Gujarat, these states, certain locations, if you make a borewell, you will get salt water, similar to our sea salt. So such salt water cannot be used for agriculture. This land will be wasted, and agriculture is not suitable for agriculture. These lands we can use for fish culture by using the salt water. So there also we are taking some kind of technological interventions and support. And only so far we used our 11% of the land which we could able to export nearly 60 crores worth of seafood. So if we are expanding this, definitely we can produce more fish for our domestic consumption by export consumption. So Government of India vision is by 2030 our export should reach 1 lakh crores. Now we are 60,000 crores. We should reach 1 lakh crores. Further, lot of schemes and support is given. So if you come to Tamil Nadu we have about 56,000 hectares Brackishwater area. Out of this only less than 11% we have used for activity, and nearly 10 lakh tons of Brackishwater fish and prawn we are producing. And the major species we are producing is Vanani white shrimp. So these are the major varieties are cultured in Brackishwater, backwater. Monodon is one shrimp which was cultured during 1990s. It started, but it had viral disease. Because the viral disease, this total sector which we are producing nearly 40,000 tons, which we collapsed and we could not breed. Then government imported a new variety from North America that we have standardized to Indian culture conditions, that is Litopenius vanani. Now today more than 10 lakh tons of shrimp we are producing in our country and we are exporting. Another one is Penaeus indicus, our native species. So we got a project from Government of India for 38 crores. We are doing a selective breeding to improve the variety. So shortly we will be releasing this variety for farmers. So our scientists are working on this project, genetic improvement of this variety. And mud crab is in Tamil we call the Kalinanda. This crab is exported live to different countries. So 1 kilo weight crab is costing around 2,500 rupees if you are selling it live, if it is exported. So this crab breeding and culture technology we are supporting to the farmers. Another variety is the fish, it is sea bass, Koduvami in Tamil. So there are many breeding hatcheries have come up in our country. This is very delicious fish. Farm gate price, when farmer is producing, you can sell it 400 rupees per kilo. When it is coming to retail market, it is worth for 600 rupees per kilo. So these are all other varieties of Brackishwater fishes which will grow could be also where it is established, having solved where it is breeding technology or scientists are working and we are trying to breeding. Coming to seabass, the custody technology was developed by our institute. In 1997, we started. In 2001, we transferred the technology to Brackishwater Center for Aquaculture, located in Chennai. And they are also having a hatchery in Dubai. They are doing the fish breeding and they are selling it. Within 6 to 7 months, the fish reaches to 750 to 800 gram size. It is sold to the market. It can grow in very low salt, like freshwater to marine water. It can grow. So that is the advantage of the fish. Another one is silver compound. It looks like our large component fish. This also has a good market. Same Aquaculture has developed the technology. We were there involved in this breeding technology. Today, at least 3 to 4 hatcheries are producing the fish and it is being marketed. It reaches about 250 to 400 gram size within 6 to 7 months. Next. Another variety of Indian compound similar to this. Around 6 to 8 months it reaches half kilo size. It has a good market demand in West Coast and East Coast. This is a red snapper, Malabar red snapper. This is like a carnivorous fish. Breeding this carnivorous fish is very difficult. Our scientists have developed the technology and we are trying to do the farming trials and we found that this fish reaches 750 to 900 grams within 7 to 8 months time. And with a good survival rate, we are transferring this technology for cage farm. So you can put in the open water bodies in backwaters, you can install the cages, you can grow them in small cages. This big fish is another variety. We have developed the technology and it is a patented technology. We are transferring the technology to many hatchery operators. Now seeds are sold to Andhra Pradesh, West Bengal and other places. Normally this fish is sold in the farm gate price around 150 to 200 rupees per kilo. Rich in omega-3 fatty acids. This is a plankton fish. By feeding with low value, low protein feed, we can grow them. So many farmers are taking technology from us and they are growing it. Another one, this one is called the Karimi in Kerala. This fish breeding technology we have standardized. The farm gate price is 250 rupees and the retail market is sold for 400 rupees in Kerala and Karnataka. Commercially, we established nearly 5 to 6 hatcheries in Kerala and Karnataka. They are producing the seeds and the very good survival rate and very tasty fish when it is cooked with groundnut oil and coconut paste. This is grey mullet, Madavi in Tamil. This also we have developed the breeding technology. This technology is many farmers are taking and the farming is very simple in polyculture method. Along with other fish also it can grow. So coming to the problems, what we are facing is more our farmers are depending on the natural resources. The dependency has to be reduced. For that we are trying to establish more hatcheries in coastal areas so that throughout the year seeds will be available. And the farming, since if you take prawn culture, it takes 24 months, whereas fish culture requires 8 to 10 months. So attracting farmers, keeping them in the business is a bit difficult task, where we are trying to give them some kind of a short-term cropping patterns also we are giving the farmers. And for carnivorous fishes, we have developed cost effective. Normally, fish feed is costing 100 to 120 rupees per kilo, whereas we have brought out around 80 rupees per kg. We are giving the technology support. And farming and the hatchery, we are giving total package of practices. Many farmers are the shrimp culture when it started in 1990. There are many corporate companies ventured into the business and they all insured their staff. So insurance companies also happily taking the money and suddenly this disease outbreak started, white spot disease. So the total sector collapsed. So these insurance companies happen to pay very huge amount as companies. So all these insurance companies decided fishery sector is not suitable. Suddenly disease problem will come and we will lose our money. So that's why they stopped insuring all our fisheries problems. Recently our institute has brought out a package and we convinced nearly 3-4 insurance companies, those insurance companies started insuring shrimp culture. Like if you go for any two-wheeler or car, anything you buy, insurance is compulsory. Like the fish culture, we are trying to make the insurance is compulsory so that farmer will not incur any loss. For the government also, the premium amount the government will give 30% or 40% as a subsidy. Government will pay back only 30 to 40%. The insurer can pay the remaining 60%. Like that of package they develop. Location specific studies also we are conducting. How much farms can be established in location just to avoid the disease outbreak. So we are establishing carrying capacity studies and say in this village you can have maximum 10 acres of farm. Another village if it is a bigger reservoir we can have 50 acres. Like that studies also we conduct and we give them advisory to the farmers. Today everything is internet based. So today the IT sector is growing everywhere. Since this conference is covering whole biology, I thought some information on latest technologies were being adopted by our farmers. Better that will be giving you some kind of thought process. So today the world is living on internet, living on IT based. So now our farmers traditionally they go for only fish culture with the traditional methods. The loss is more. So to come how to control the loss, how to reduce the production cost. So latest technologies are available to effectively culture the fish with the minimum expenditure. Further, IoT, IoT-based applications, our scientists have developed and private sector also has developed, like automated feeders. So if you feed the fish, it is whether it is completely taken feed or not, we don't feed. Our farmers simply throw the feed into the pond and they come back. But today the automated feeders are available, smart feeders are there. Automated feeder, you load the feed and program the machine, it will feed first 2 meters distance, then it will throw the feed after 5 meters, then 10 meters. So like that it can throw feed in different directions, like how gun is firing, like the different directions, different distance he can feed. So if feed fish has not taken feed, then we will check sufficient feed is not there. So we put a small tray in the pond, we will add little 100 grams of feed and we wait after 1 hour of feed. After 1 hour of feeding, some shrimp is coming or fish is coming. And feeding it does not fit area, so its stomach is not full. So it's simply a person working in the farm, he can take a photograph of tray, how much feed is consumed, how many shrimp are there. So AI-based, artificial intelligence-based programs are there, where this image, when we are loading into our software, this is sharing of app. He has to open an app and share the photo. That will calculate how much feed is taken. Next feeding schedule, how much feed we have to increase. So that will be remote monitoring control system also we have. So this program is integrated with your weighing machine. So if you have 10 ponds in a location, each pond will have at least 2 to 4 feeding trays. So how much feed should be dispensed in the pond? That will automatically this weighing machine also will calculate, and trays will have the barcode. You keep the tray, it will recognize the tray, this particular location is tested. So that much quantity only will dispense the feed. So like precision farming is one of the important one. And data-driven decision systems. Like if you are installing a water quality monitor, it is directly connected to satellite. It will take all the water quality parameters, whether you have to change the water or not. It will give a decision supporting your app itself, it will give a suggestion. Now the water quality, salinity level is low, pH level is very high, oxygen level is very low. You have to switch on the air. So all these suggestions, all artificial intelligence based technologies have come into our system. So this IoT plays a very, very important role. You need not be present in the farm. You can sit in the boat, you can monitor everything. Today you have the startup control. Suppose the oxygen level is low, you will get alert to your mobile phone stating that the particular pond oxygen level has from 8 ppm it has dropped to 6 ppm. So automatically from your mobile you can just start the pedal wheel aerator. So once you start the aerator will generate, it will once oxygen level reaches 8 ppm, automatically the aerator will switch off. Like that we can program. There are IT people are working in this sector, they are giving the programming based on our requirement. Like this auto feeder, then pond profiler, aqua documentation, then smart weighing machine, all these now coming to increase and last 4 years these technologies are coming. So this is about the automatic feeder. So automatic feeder will have a feed dispensing system, which pond how much has to be dispensed, how it is dispensed, everything you can monitor from your mobile. Mobile based applications are This is a small starter which I told. So based on the oxygen level, you can make a decision. You can switch on particular aerator or particular pond. This is possible. You can reduce the electricity consumption at the same time effectively. You can, without any stress, you can grow the fish or shrimp. That is possible. This is a pond profiler. It will monitor the dissolved oxygen level, pH, COD level, POD level, ammonia, how much sludge is accumulated, waste is accumulated in the pond bottom, any soil abrasion. So this is fitted in the pedal layer. Like a robot, it will be moving within the pond and taking the sampling. It will give you average data to the satellite. From satellite, it will give a data. So that kind of precision support system also there. This is a Aquaculture where you can cloud-based system where feeding you can monitor. You can exact the quantity of feed you can use it for each feeding system. Next. So each pump we can customize. I am having only 2 pumps. For the 2 pumps we can make a app, and whatever the water quality requirement, monitoring everything, we can install the equipment, we can integrate it. Just sitting in the mobile, with the mobile we can monitor everything from home. These kind of technologies were not there 5 years back. Now today these technologies are available. Next is the drone-based application. Drone, people are thinking that the drone is used only for just applying fertilizer or pesticide in your farm. Drones are going to make a big revolution in another 5 to 10 years. People are working behind with so much of technologies which we never thought of. Today I am having agriculture land 1 acre. I have a tomato plant is growing. So one drone making a 5 minutes visit, it can say how many tomatoes are there, what is the size of the tomato when I have the harvest. So that kind of applications are getting ready. So if you are growing chili, how much chili are grown in your land, and how much fertilizer has to precision fertilizer with the 1 millimeter height or 5 millimeter height or 5 centimeter height. Whether fertilizer has to be applied or you don't apply the growth stimulant, anything is possible with the drone. So drones are making big going to make a big revolution in agriculture sector. And another one important area in fisheries also. Like you can apply the feed using drone. You can monitor the water quality parameters with the drone. In open water cages, in other countries already they started using drone-based application where you can monitor the fish, you can feed them appropriate time, you can take samples, the samples can be easily transported to different locations. All these are happening slowly. The IT sector is into fisheries and they are giving a lot of back-end support for our culture activities. Next. Then again, satellite-based applications I was studying. Today, if you see as per the 2022 data, we have nearly 8,261 satellites circulating above our orbit. India is having about 124 satellites. Out of which only out of 8,261, 4,850 satellites active satellites. Other satellites are like e-waste. They are just only under our orbit. They are just rotating the sun. So these satellites can be effectively used. We have about 124 satellites which are all function. Next. So satellite-based applications, our scientists are working in association with ISRO. We develop various kind of technologies. Whatever each satellite is having a different type of sensors are there. I was telling you about fish finder. A simple example. So the satellite will have a sensor for assessing chlorophyll. You must be knowing chlorophyll. Chlorophyll is present in the leaves. So if leaf is having chlorophyll, the leaf will be green in color. So this chlorophyll taking sunlight, they synthesis oxygen and at the same time they produce. So likewise the chlorophylls are present in the algae, microalgae floating in the sea. So the sensor from the satellite can scan and see how much of algae is there in a particular location. If algae is more, that means all plankton feeding fishes will be aggregating to hunt that all carnivorous fishes will. That is the basic strategy. So if satellite is sensing in one particular location, more algae is there, that means more plankton fishes are there. To feed these plankton fishes, all carnivorous fishes will. What is the latitude and longitude? That data we will get, that will designate to the fishermen. They will go from this nautical mile distance, you go and encircle the fish. So that kind of information also we share with the farmers. That is being done by the Central Marine Fisheries Extension. Again, now you are located in a place where a lot of shrimp farms are there nearby. This shrimp farm data, many data is government is synthesizing. We cannot, I personally cannot visit hundreds of farms in every location, but I can get the data, satellite data, and my scientists, my team will work and they will analyze which pond is in production, which pond is not in production. If water is there, that is culture is going. If there is no water, then there is no culture active. Like this, we can take at least 3 months consequent data, we can analyze. If it is monsoon, fed water is there in the pond, there is no fish culture activity, that will try within 2 months. So normal culture activity means it will continue for 8 to 9 months. So based on that, we can assess how much production currently going, how many farms are live, whether these farms can produce how much quantity of fish or not. That data also we can monitor. So we can integrate with the marketing. So this much production is going to come out. These farms, when they produce, whether it has to go to export or going for domestic consumption, we can monitor. Likewise, individual pond-wise satellite image data, we can use it for analyzing the growth parameters, water quality parameters. So such kind of information we can get it from these satellite sources. So as I told you earlier, nearly 20,000 crores, 20,050 crores, now recently another 4,500 crores added for development of the fisheries sector in the country. This funding is coming from the central government. Through the state government, they are beginning to develop infrastructure within the country, and also to today, if the fish is caught in Kumbura, it has to reach to Calcutta. It takes about 4 to 5 days by road. By air means it takes at least 12 hours. It has to go to Chennai or it has to go to Trichy, and then it has to airlift. So until it reaches the marketing point, the freshness has to be maintained, and then it will get a better price. So that kind of marketing infrastructure, cold chain, we have to develop. For the government is investing so much of amount. Another one, a small fishing harbor. Maybe holding some 50 small crafts. So if you are upgrading these fishing harbors, if the fishermen are given a better big size boat, if they are trained to fish in deeper waters, we get a higher value fishes. So for that we have improved our harbor infrastructure. There also government is investing a lot of money. So with this I will conclude. I thank my director, Dr. Jayakumar, who was permitted to be here, and I thank all the organizing committee of CSDS. Thank you all for your patient hearing. Thank you. Thank you.